Hello guys, welcome back to our channel Biolab, and this is Vamsi here at Biolab, and in today's video we will be discussing about the GFR, like glomerular filtration rate, and also a little part of juxtaglomerular cells. All those we will be discussing in this video, guys. And before entering into the today's video, a small revision about the previous video or the yesterday's video which I have uploaded. That I have told you about the formation of primary urine, right? Formation of primary urine, and I have explained you that if this is your Bowman's capsule. A small recap, guys. Again, we'll be moving on to today's video. If this is your Bowman's capsule, this would be your glomerulus. This is your efferent arteriole. This is your efferent arteriole, and the efferent arteriole, it is thick than the efferent arteriole, guys. We have to remember this point. Efferent arteriole thick and efferent arteriole thin. Okay, this point we have to remember it. Now when the blood enters the glomerulus through the efferent arteriole, it passes through the glomerulus and through the filtration membrane, which is here. This is your filtration membrane. I have already told you what are the components of filtration membrane. I will not again explain you. The plasma, water contents in plasma, nutrients, some nutrients, not all. Next, glucose, amino acids. These are the things which are necessary for our body. If these are not there, if these are not present in our body, we cannot, the survivability would be difficult. So that is why what happens is, when these all things are passing through the urine formed here, this is your primary urine formed, and this primary urine consists of all these except the RBCs and WBCs and some plasma contents, because they are large in size. This filtration membrane is so small. It is very small. Even though it is having 3 layers, it is small. It is thin, very thin. And since we have here podocytes and the pores on that, filtration pores are filtration slits are too small. Much of contents cannot, larger size contents cannot pass through them. So this primary urine formed has to be reabsorbed in order to get these contents back. So that process of reabsorbing these contents is done through the rest part of the nephron, that is your tubular part. This tubular part does the reabsorption. Reabsorption means again, absorbing. So this is the process in which the tubular part of the nephron absorbs the essential nutrients, water, glucose and amino acids, or essential components simply, into our body, is called as reabsorption. Okay, that is your reabsorption. But before moving into this, this primary urine formed per minute is, so I have already told you this. Now please answer me in the comment section below before I again revise you that concept. What is the primary urine? So mention in the comment box now, what is the primary urine formed per minute? I am again underlining formed per minute. Now give me. and also what is the primary amount, what is the amount of primary urine formed per day. Again I am highlighting day. Now both are very important, we can get confusion here. So 1 minute. What is this? It is 25 ml per minute and 180 liters per day. Okay, here you can strike out minute and day since we have already mentioned them here. Strike them out. 180 liters of primary urine per day and 125 ml per minute of primary urine. And this 180 liters per day or 125 ml per minute consists of those all the essential components which I have told you before. So in order to remove those and produce only an urine of 1 to 1.5 liter per day, not per minute, per day, we do selective reabsorption, and that reabsorption is already done, is being done by tubular part. I have already told you. Now what is this called as? This is called as per minute. This value, the formation of primary urine or the amount of primary urine formed per minute by all the nephrons, by all the nephrons, not one nephron guys, by all the nephrons, it is 125 ml, and this is called as GFR. What is GFR? Glomerular filtration rate. This is called as glomerular filtration rate, and this is 125 ml per minute, 125 ml per minute and 180 liter per day. Remember these values. GFR. What is the GFR of a kidney? Define GFR. It is basically the amount of primary urine formed per primary urine formed per minute by all the nephrons of both the kidneys, not one kidney, by both the kidneys per minute is called as GFR. That is nothing but glomerular filtration rate. Now you can get a doubt how this urine or primary urine formed is able to move all throughout the kidney, like the tubular part, all throughout the kidney. How is it able to move? That is because of the, this is called a GFR. That is because of the, listen to me very carefully, this is important again here. You can get a confusion between these two terms. Listen to me. Listen to me. Okay? Listen to me. No. That is because of the net filtration pressure. So wait guys, let me check this. I'm not very sure that it is net filtration pressure. 1 minute. Yes guys, it is net filtration pressure, right? And this net filtration pressure is the one which is responsible for the movement of urine all throughout the kidney. All throughout the kidney. We have to remember this. And this value is equals to 10 mm of Hg. 10 mm of Hg. 10 mm of Hg. How this 10 mm has come? We have different types of pressures in kidney, and that sum, or you can say the difference between those pressures gives you the net filtration pressure. Why to take a difference and all? We do not require those. Just remember the pressures which I am giving you here, the values of the pressures. Glomerular, hydrostatic blood pressure, which is equals to 60 mm of Hg. Next one, glomerular blood osmotic pressure, which is equals to 32 mm of Hg. Next one, CHP, which is equals to 18 mm of Hg. Hydrostatic pressure. And when you if you want to calculate this, why these two are against to this one. The glomerular blood hydrostatic pressure is against to glomerular blood osmotic pressure and CHP. Now how to calculate this net value? GHBP minus of GBOP plus CHP, and that gives you 60 minus 32 plus 18. 1 minute. What is happening here? Please wait a minute, guys. So yes, there was some issue with the net. Yes, this is common. Now we were discussing that how to calculate this NFP, right? NFP, net filtration pressure. GHBP plus of GHBP minus of GBOP plus CHP. This is your 60 minus of 32 plus 18, 60 minus of 50. This results in 10 mm of Hg. So this is how, with this 10 mm of Hg pressure, the urine passes through different parts of the nephron. And now let's move on to the today's topic, that is your watch. That is, yes, come on, tell me fast. And today's topic that we are discussing is your reabsorption topic. Put the side heading reabsorption. Sorry. 1 minute. Before going into this topic, let me give you that this GFR can be regulated by the is JAG. What I'm talking, JGA, by the JGA, glomerular apparatus. Dextra means beside glomerular apparatus, and this juxtaglomerular apparatus consists of two, that is, one is macula densa, and the second type of cell that this contain this JGA contains is JG cells, juxtaglomerular cells. And where this juxtaglomerular apparatus is formed is, it is formed at the place of close contact between the DCT part and the afferent or efferent arteriole, AAA or EA, and this is your DCT part. At this place of contact, this is present. and macula densa cells are present in the DCT part here, not all, at only the place of contact, and JG cells are present on the efferent or efferent arterial part here. Now this forms your juxtaglomerular apparatus. This can regulate the glomerular filtration rate, and how it is through an hormone called as renin, not renin but renin. Renin, it is milk hormone that we will not be discussing here. 1 minute. It is renin, renin. This renin, it is secreted by JGA, and this renin regulates the functioning or regulates the glomerular filtration rate. How we will be discussing in the regulation of the formation of urine there. It comes after 1 minute, here only. Let me tell you where it is. Yes, it is 19.5 of your textbook. It says regulation of kidney function. There will be 19.5 of your textbook. We'll be discussing there. Okay, regulation of kidneys function. There we will be discussing this. But now let us start with the reabsorption topic. See, this reabsorption I have already told you, it is also called as, again the same problem. 1 minute guys, please wait a minute. So yes, reabsorption I have already told you, this is also called as selective reabsorption, because we are selecting what are the materials that we know to be reabsorbed. Okay, this reabsorption takes place, I have already told you all this, takes place in the tubular part of nephron. Tubular part of the nephron. Okay, takes place in the tubular part of nephron. So wait a minute, let me talk about it. Okay. Now, at some places we the tubular part of the nephron includes TCT, descending limb, ascending limb, DCT, initial ICD, initial collecting duct, and CD collecting duct. Proximal convoluted tubules, descending the limb of loop of Henle, ascending limb of loop of Henle, the distal convoluted tubules, initial collecting duct, and collecting. So these all are composed of the tubular part of the nephron, and they help in the reabsorption. Each part helps in the reabsorption of different types of things, and that is clearly mentioned in your NCERT. Now here we have a controversy that yes, let me try to show you the NCERT. Please wait a minute here for me. Yes, hope you can see my NCERT here. Let me zoom it a bit, and then here we have a small controversy that about this we will be discussing in the next lecture, guys. Counter current flow and all this. See a little zoom out a bit. Yes. Now see. Here in the running matter, let me show you that running matter. Here The PCT also helps to maintain the pH and ionic balance of the blood body fluids by selective secretion of hydrogen ions, ammonia, and potassium ions into the filtrate by the absorption of uh, HCO3. Now see this. This actually what happens is not only reabsorption, not only selective reabsorption, selective secretion of some different kinds of materials or different kinds of ions is also taking place. Here they have written that potassium is being here see this this part. Potassium ions are being selectively secreted. Potassium ions are being selectively secreted. So see here this part. But when you come to the diagram, we actually one minute. Let me show you the arrows which we represent. See this. We actually represent the absorption arrow like this. If this is the tubule, we represent the absorption reabsorption arrow like this and secretion arrow like this. This is absorption arrow, secretion arrow. Okay, now coming to the diagram given in your NCERT. See, so this I have to tell you guys, since which is correct we have to know. See here, what is the absorption arrow? Arrow upwards, away from the part, away from the tubular part. See here, K plus, here they are saying K plus is being reabsorbed into the body fluid. K plus is being reabsorbed. But whereas in the lines of NCERT they told that K plus is being selectively secreted, and this is false. K plus is not selectively secreted, but it is selectively reabsorbed into the body in the part of PCT. Okay, so why I have stopped the lecture and told you this is because this is a mistake which is given in your NCERT. Maybe it is a typing mistake, we don't know. This is correct, this part is correct, this part is correct, this is very correct. In the PCT part, now let us talk about the materials. Leave that apart. Now come to the today's lecture. Let us talk about the the materials which are selectively reabsorbed in the PCT part, proximal convoluted tubules. Nearly 70 to 80% of the blood is being reabsorbed in the PCT part. Here it is a given line in your NCERT that 70 to 80% of the electrolytes and water are being reabsorbed in this segment. Now let us come back to our whiteboard. In the PCT part of your nephron, reabsorption, put it like that. PCT part, put it like that. This one. Here in the PCT part, points, you make a points 80 or 70 to 80%, 70 to 80% of electrolytes are being reabsorbed. What are being reabsorbed in the PCT part? K plus, reabsorption only, not secretion. K plus, remember, K plus, glucose, amino acids, NaCl, next NaCl, water, hydrogen carbonate, HCO3 plus, HCO3 minus. These are being reabsorbed. But what are the materials being secreted? Why should they be secreted? They should be secreted. These materials are not required for our body and in order to also maintain ionic balances. The materials which are secreted are hydrogen ions H plus and ammonium ions. These are being secreted, these are being reabsorbed. Potassium, it is a controversy, but we have to take it is being reabsorbed only. Okay, where does the glucose reabsorption takes place? PCT part. Where does the nutrient absorption takes place? Nutrient, also add nutrient. Where does it takes place? In the PCT part. Where does the NaCl absorption takes place? In the PCT as well as DCT. Where does water reabsorption takes place? PCT. Where does 70 to 80% of the electrolytes are being reabsorbed into the blood again? In the PCT part. Now the remaining 30 to 20% of the electrolytes will be reabsorbed in the remaining parts of the remaining tubular parts of the nephron. And in next video we will be discussing about all of this, and we will be completing this one, and then we will be moving on to the mechanism of absorption or concentration of filtrate. So that is it for this video, guys. If you like the video, please hit that like button and also subscribe to our channel Biolab. And this is Vamsi signing off from Biolab. Have you a great day further, guys. Thank you.